Hi everyone, this is a video that's going to talk about how to find the hole-in-one route and then how to apply the distance formula for the parts of our mini golf project. So I have a sample miniature golf hole here. This is simple, or similar I should say, to the design that is in the Google slide presentation, the area and the perimeter, and now we want to talk about how to get the hole-in-one. So if you were actually playing this mini golf hole, you would probably say, notice I've kind of put a yellow dot where the starting point is. I'd probably say, well, I got to bank it off this wall to get it into the hole like that. Now, I can't just say that I'm going to hit that ball perfectly and it's going to hit the wall over here on the right hand side at that spot. Um, so what I need to do is I need to actually um, do some calculations. So here's what we're going to do. When we look at the reflection wall, um, that is the wall on the right side here, I need to actually basically work backwards from that. So I need to count the number of spaces it is from the point to the actual, from the miniature, from the hole to the actual line of reflection, the actual wall that I would bank off of. So if I count here, 1, 2, 3, 4, 5, 6, 7, 8, 9, it's 10 units to that wall, then that's the number that I would have to basically reflect over here. So um, 1, 2, 3, 4, 5, 6, 7, 8, 10. So that means that my reflection point is going to be out here. Okay, and this is what we it's more commonly referred to as pool table geometry. If you were playing pool and you'd see the diamonds on a pool table, you are actually trying to bank off those diamonds. So that's what we're kind of doing here. So now what I'm going to do is I'm going to draw a line from the reflected point back to my starting point. So it would look something like this. Okay, and then from where that spot is, you see where it intersects on the wall right about here. I'm making that purple dot. I would then draw a point from that spot to the hole. So the actual hole-in-one route would be, what I'm going to highlight in blue here, would be this distance right here. Okay, and so that is what we're doing right now, is we are finding the hole-in-one route. That's how we would do the reflection. This is kind of just one bank. All right, if I wanted to bank off of a second hole, I could do that, and there'll be a video for how to do that as well. But now I want to talk about how would I find the distance formula. So based on this here, I have my points, and I'm going to use this point here in the center. You can kind of see I have some axes here. This point here in the center would be 0, 0. That would be the origin. The golf ball is located at, looks like -5, +3. The point on the wall that banks off of would be roughly 7, -1/2. Now, I'll be honest with you here. This is something where you use your best estimate on where it hits the wall. Okay, if it's close to the line, then go to the whole point. And then the hole is situated at -3, -3. So to find the total distance here, I really need to do some distance formula calculations. I need to basically find the distance formula here for this first one, and I'm going to basically do these by like doing Pythagorean theorem triangles here. And we'll do a different color. There we go. So I want it. Now you can do distance formula like that was done in the video. So I would basically need to, I could think of this as a um, Pythagorean theorem calculation. The distance, the x distance here would be 3.5. And the distance from the point all the way over is going to be 12. So then I could do, to find the first part of my distance here, I could do basically 3.5 squared plus 12 squared. Do the first part of basically Pythagorean theorem. And then take the square root of that, and if you add those together, you would get 156.25. So the square root of that is approximately 12 and a half. Now remember, in this case, it's 12 and a half feet. Every one of these little squares here is equal to 1 foot. Okay, so this is roughly this answer right here. That first part is 12 and a half feet. Now for the second part of our miniature golf calculation, the distance formula calculation, we're just going to do that last part of the triangle down here and find that distance. So that distance here, as we're looking at our measurements, looks like it would be 10 on the bottom here, and from -3 to -1/2 is 2.5. Now I'm not worried about the negatives here because I'm really finding the positive distance here. So it'd be 10 squared plus 2.5 squared. Doing Pythagorean theorem calculation once again, which is that equivalent of the distance formula. And when I do 10 squared plus 2.5 squared, I would get the square root of 106.25, and that comes out to be 10.3. And then finally, what you would have to record is the final distance. So I just have to add here. We need to add to get my total. I'm just going to put this in a little box here. To get my total here, I would just add the 12.5 plus 10.3. So the hole-in-one route total distance would be 22.8 feet. And that would be something that I need to calculate. So when you look at the Google slide for information, you'll see what the area is, what the cost is, what the perimeter is. You have to include any interior walls, and then what the cost for those making the walls, or the bumpers as some people call them, the hole-in-one route and the distance. And then finally, don't forget to add the $5 that you would have to put the miniature golf hole there. There will be another video, like how do you bank off of 2 walls, if you decide to make your own design that would incorporate banking off of 2 walls. So happy planning.